Well, hello everybody. I've got a lot of progress to report and a little bit of a story to tell you. So just to bring you up to speed, I've replaced these transistors, and I told you earlier that I was going to trace the wires out, and I've done that. So they are now installed correctly. So those are brand new. Those are two N3772s, and they've both been replaced. Very simple. There's actually little sockets they plug into. This cap you've seen. Got a lot of progress in here, and you'll notice that there's a lot of resistors in there that are new. Those blue resistors are all new. And you're going to ask why. So let me explain a few things. I've replaced this cap since last time, this one, all of these blue resistors, this one, etc. Okay? And I was able to power it on, and I was able to use the amp, and then this happened. So this resistor right here, which was sitting where this one is, started to leak some oil. Okay? And I looked on the circuit board and I saw some oil, so I turned it off real quick, of course, and no smoke or anything like that, but I noticed that oil was leaking out of the cap. So that made me wonder what the heck was going on. So then I looked around and I saw that where this 15 ohm resistor was, it was actually burned, but it wasn't a new burn. It was burned pretty much at the same time that this one became totally gone, if you remember. So I said to myself, well, something's not right in there. Something's not causing things to react properly. So I went to the schematic, and I look at the schematic, and here's the 100 ohm resistor that was burned beyond recognition. Okay. Here's the capacitor that I replaced. If you recall, that one is right here. This is the one that had the scorch marks on it when I first opened up the box. And if you come right around here, here's the 15 ohm resistor that I said was scorched. Okay? So I said to myself, well, what's going on with that? So I have to admit, being an antique radio repair person, that's how I started off in this. There's something on here that I've never really dealt with before, and that's diodes. Okay? So I generally know what a diode is, but in this case I said to myself, well, what could be causing excessive current or voltage to get to these components to smoke them out? So I traced this line here and said, okay, this goes up to this 100 ohm resistor. Okay, this one comes across, goes through a capacitor, comes across, here's a 15. What could be really going on here? Well, that prompted me to pull out these diodes. Now, I'm going to be honest with you. I've never really worked with diodes before, like I said, and don't know a lot about them. So here's the two diodes that I pulled out, and no indication of what value they are at all, except when I look here on the schematic, I see something 0.7. Can't really tell. So, what was I going to do? Well, when you look at these diodes, I'll see if I can show you in the light here. There is a number on them, 55 or 56-44. Okay, and they both have the same value. So what I ended up doing is going to a website which shows you a Heathkit part number cross-reference, and I was able to determine that these are 4.7 volt diodes. But then I said, what's this thing? Why is that squiggly? And why is that one straight? Okay, so that caused me to have to do a little more homework. So but before I did that, I threw these things on the meter. Okay, one of them I was able to get a reading across of ohms. One of them was dead short, I'm sorry. Okay, so two diodes of the same exact value behave differently on the meter. What's that all about? Well, I think I'm going to try to explain it to you. Now, I'm going to put a little disclaimer here and say, you know what, I'm not an expert on this stuff, but I'm going to explain it to you the way I understand it. Okay? So let's do that. So I think we all know what a diode is. All right? A diode, typical diode, looks like this. Okay? And what they typically do is they let current only flow in one direction. Okay? Nothing can flow in this direction. That's what blocks it. Okay? However, when you have a diode like this that has this squiggly line, that's called a Zener diode. Now, what does that mean? Okay? So a Zener diode is a little bit different. So what that does is it allows current to flow in this direction and in this direction. But in the case of the one that I'm dealing with, it's rated for 4.7 volts. So what it's supposed to do is it'll let anything below 4.7 volts flow in either direction. But once more than 4.7 volts hits the diode, it's supposed to close it and block it. Okay? You with me? So if it's closed, it's going to block it. Okay? If it's less than 4.7 volts, it's open. It's going to let the current flow. So, how does that fit into my problem? Well, let's take a look at the schematic again. You'll see here, on this 100 ohm resistor that we were talking about, there's a voltage mark right here of 38 volts. That's coming right off of this filter cap. Okay? Comes here, goes up, 38 volts. Okay? If you come over here, follow the line, look here, here's 50 volts. Okay? Look here, here's 3 volts. So we've got different voltages flying around all over the place here. You've got 3, you've got 50, I said 38, that's wrong, it's 50. So you've got 50 here, you've got 3 here, you've got 50 here. So what that means is that this rail, right over here, has 50 volts flying on it, and this rail has 3 volts flying on it. So what do you think these diodes are supposed to do? Okay? Well, first of all, it's supposed to prevent more than 3 volts from getting to this capacitor. It's a 100 microfarad 3 volt cap. So if more than 3 volts came flying across here, which is, by the way, this cap right here, this is the one that had oil leaking out of it. So what does that tell you? That tells you that one of these diodes is bad, and it's allowing more than 3 volts to come through here. Okay? Actually, the cap is 4.7, if you recall, right? So that's the most that can come through here. But if one of these diodes are bad, the possibility exists that 50 volts can come flying through this and come here, ruin that cap, come down to Q14, right, which is one of the 4410 drivers that I've replaced, which is right there. Remember I told you they were bad? Take this out, possibly, okay? Come across here to the collector of Q12, come back up, and there's my 15 ohm resistor that was slightly burnt but not gone. So my current theory is that these Zener diodes are bad, or one of them is bad anyway. I don't really know the right way to measure them. I'm going to show you what I get, and then we'll determine what may or may not be right. So let's get up the old meter. Okay, so we're going to test these two diodes and we're going to see what's going on with them. So let's go here. Here's our first diode, okay? And we've got our meter on diode check, and we're going to test it and see what we get. We're getting 0.62 volts DC, okay? Let's swap this out, put the other one there. Okay. Let's see what we get. Not good. So what does that tell us? It tells us that the two diodes are different, and something is wrong with one of them because they're exactly the same diode. So, in theory, I'm thinking if one of them is shorted or stuck open, it's going to allow anything it wants to pass through here. It's not going to shunt over the 50 volts, which are coming from here. So, in theory, I think that's probably what blew the components on this board, which was this resistor. Remember, it was gone to pieces. This capacitor was smoked, and these drivers were in bad shape. So, I think I'm close to root cause. I'm not exactly positive. I need to learn a lot more about Zener diodes, but I think that's what's happening here. Okay? Anyway, to continue, I've replaced all these caps. These are all new. I've taken off the knobs on the unit right here. All right? And what I did was I've cleaned the knobs out. You see they're all here. The beauty of these things is they're all aluminum. Okay? And you can clean these things pretty easily. I'm using WD-40, believe it or not, to get these clean. They're not coming clean at all. There's a lot of gook on these things. So I'm working on these. I haven't done this one yet. This one's got spots on it. So I'm working on the knobs. I've also have to do this. I've got to fix that yet. Of course, you know what that is. And I started to look at the case. Okay? So this is the back of the case. And the Tolex, look at that Tolex. So what I did there is I used the Tolex conditioner on it. I had to glue some of the corners which were coming out. But that Tolex doesn't look half bad. So what I think I'm going to attempt to do is the rest of the cabinet, I'm going to try to glue it down and see if I can restore it and use the original Tolex. Remains to be seen yet. But for this series, I just wanted to show you what was going on with this diode. I'm waiting for the new diodes to get in. Once I get the new diodes in, I'm ready to turn this thing on and start playing with it. I think it's going to probably work very well. I also sprayed some deoxit on all these switches and knobs to try to clean up the contacts because they were a little crackly. But I think we're on our way to being close to wrapping this one up. By the way, when I was changing these resistors, I found that almost every one of them was way out of spec. These were okay, but I may change those anyway, being that I have the resistors. So that's kind of where we are. This is the power amp section, by the way. So, you know, very consistent with the issues that I was seeing with the unit. Anyway, I'm going to wrap it up. I hope you don't mind my non-layman explanation of diodes. It's certainly not going to be scientific, but I think you'll get the gist of what I was talking about. All right? That's it. This is Ron.